Hello folks. So in today's video, we will code this very popular Tetris game using JavaScript. So what do we have here? We have different pieces in different colors, and what we want to do is form lines at the bottom, because when we form lines, the lines will disappear and we will get points instead. So I believe we are very close to forming a line. We need two good pieces, and I think now we only need one. So I don't think this is a piece that we want to fit over there. Let me just keep it here for now and we'll wait for a different piece. So this one is good. So the last line disappeared and we got a score of 100. And we are very close to making a score of 200. And we have 200. So let's see how we can code this using JavaScript. So in my VS Code, I have a very self-explanatory index.html file. I have a body and a canvas. um, and we have some little bit of styles: background color of black, color of white, border of white. Very simple stuff. We are also connecting a script.js file, which is currently empty, and here we will define our canvas equals to document.query selector canvas, and then we'll create a context to draw. So canvas.get context 2D. We will also give some dimensions to our canvas. So canvas.width, let's give 500, and the canvas.height also will be 500. We will give some values to our site, let's say 50, and then we will have 10 rows and we will have 10 columns. Now in our complete Tetris game, we have a 20 cross 20 board, but initially we'll start with 10 cross 10, and then we can scale it up. Scaling up is not really difficult. We only need to change the initial values and the rest of the things will follow. So here we have the things ready more or less. So let's see how does it look in our browser. So I'll come here and I will open with live server, and this is how it looks like: an empty canvas for now, and soon we will have a game over here. So after defining the side rows and columns, so we need to define some colors. Now, initially, different shapes will have different colors, but later I want to like we can randomize later if we want, but for now we will identify shapes with colors, and we also have to give some dimensions to our shapes. Now we had lots of shapes in our game, but initially I would like to start with only three shapes. So let me give the colors of red, blue, and yellow, and I want three shapes. I want the I shape, the O shape, and the third one being let's take the J shape. So what are these shapes? If we go to our game, this is the S shape. We are not taking it right now. And this box, this looks like a small O, so we call this the O shape. And this one, this is the L shape. Now there is another which is the opposite of this one. That is what we call the J shape. So yeah, so this looks like a J, so this is what we call the J shape. And the long line, this one, this is what we call the I shape. So let's give them some dimensions. So regarding our I shape, if you think, what will our I shape look like? Let's say the first index is 0, 0. We will need four indices, and it will actually be 0, 0, 1, 0, 2, 0, 3, 0. Because the first unit is the x and the second one is the y. So the x is representing the rows and the y for the columns. So in the 0th column, and we have four rows. So if we go to our board, so let's pick one index to be 0 for the column, and four rows: 1, 2, 3, 4. So this is how it will look like, and this is why this is the I shape. Now for the O shape, if you think carefully, again, if the first one is 0, 0, what will the other indices be? This will be 0, 1, then 1, 0, and the 1, 1. This is for the O shape. Now regarding the J shape, it may look tricky, but believe me, it's not. So it will be 0, 0, and then we will have a 0, 0, then 0, 1, then we'll have a 1, 1, and then we'll have a 2, 1. So let's try to understand why this is the case. So let's consider the 0, 0. This is, let's say, one particular index. So we will move the column by 1, and in the second column, we will have 0, 1, and 2. So if we compare, this is the L shape. So here, consider this one. So we already got a J shape. So this one is the 0, 0, this box. Then this is 0, 1, and then, I mean 0, 0. Then we have the 0, 1, 1, 1, and 2, 1. So 0, 1 for this blue, 0, 1, 1, 1, and 2, 1. So we got our three shapes and also the colors for our three shapes. So for the red, let me give it to the eye. The blue, I will give it to the small o, and the yellow, I will give it to the shape. So we have these things. Now, how can we start our game? So let's consider, we will start our game. And as you can see, it is almost like an auto game. So every second or half a second, um, it will come down. And once a piece is like piece is like piece has stabilized at the bottom, another piece will start coming. So so we have to create some sort of an auto counter. Let's consider every step we are updating. So we'll create a function called update. Now this update function need to be called, let's say, every interval of half a second, so 500 milliseconds. So this is how we'll call the update function. Now we'll create a function called update, and this update function will basically do stuff for our game. So first things first, we need to check that the game is running. So we'll check if the game over is true. Uh, then we'll do something else. And when we have the game over to be false, then we will play our game. So, so what is a game over? We haven't defined any game over. So the game over will be a variable. And let's also define few more variables that we will need below our shapes. So we'll need a game over. So we'll start it with false. That means the game is running. Then we also need a board. So the board will be a two-dimensional array. So what I will write is array of rows dot fill and dot map. So what I want to fill with initially is with null values. So array of calls dot fill null. So we are creating an array of rows, and we are filling it with a map of the array of columns where every value we are filling with null. So what does it mean? It means basically it will create a 2D array where every value is null. So if we are here, and so this is what we are getting initially. So we have our board, and then we'll create another variable called current piece. Right now no piece is selected, so this is also null. And game over is false, and we'll also calculate a score. So initially the score is 0. So so these are our variables. Now in our update function, uh, if we have a game over state, we want to do few things. We'll do it later. But let's say we are not in a game over state, then what we want to do? We will check if we have a current piece or not. So if we don't have a current piece, in that case, we want to create a current piece. So current piece equals to new piece, This is a function that we have to write, and let me write it like this. And so we have to create this function. So above the update, let me create a function called new piece so that we don't have errors. And once we have a new piece, let's say, so we have a current piece equals to new piece. In that case, we have to check that if the new piece has the space to move or not. So we'll create another function called can move, and inside the can move, we'll check if the current piece can move like 1 unit downwards. So let's say the current piece is in 0, 0, and we'll check that can the current piece move to 0, 1 or not. 0, 1 basically means like 1 downwards, that's all. And so x and y from xy to be 0, 0 to xy to be 0, 1, can it move is all we are checking. Now inside, if we can move, so the current piece dot y, I want to improve it by 1. Now we haven't yet defined our current piece, but the current piece will definitely have an x and y, so we want to increase the y. And otherwise, let's say the piece cannot move, it doesn't have space. That means it has already stabilized at the bottom. So in the bottom, I want to merge all of our pieces into one single piece or something like that. So we'll call a function called merge. This is again something that we will write. Can move merge these two functions. And lastly, we have to draw. So a lot of things we have to do. We have a new piece. Then we have a function called can move. So the can move will accept an x and y. And we have to write this one. And after the can move, we have another function merge. So this is when our pieces have stabilized. So we have to write this function. And lastly, we have to write our most important function, that is our draw function. So we also have to draw our board. So let's start with our draw function first of all, because let's see something at least in our screen. So we are calling our interval, like our update every half a second. So the draw function will be repeatedly called. So we will start by clearing our canvas. Canvas dot width, canvas dot height. This is something we do regularly, so no issues with that. Now let me draw the grid first of all. So we'll draw grid. Grid means the lines. That is all we are drawing. So ctx dot stroke style. Let me give gray, and here for let me give y equals to 0, and y should be less than my rows, and y plus plus. For let x equals to 0, x should be less than cols and x plus plus. And then what we need to do is we'll do a ctx dot stroke rect. We'll do an x into side, not shape, side, and then y into side, and then we'll do a side. Now if the board already contains a piece, then what we want to do is we want to fill that board also. So uh, for that purpose, what we want to do is we want to check if the board yx already contains a piece. So right now the board yx is null. We have already seen that. So we have removed that, but we have seen that. But when we have a piece, we don't have a null value. We have a different value. So in that case, what we want to do is we want to change the fill style to board of yx. So the shapes are different colors, so the fill style will definitely become some sort of a color. And then instead of a stroke rect, what we will do is we will take a fill rect. And this is what we will do. Right now it won't have anything, but yeah, for now we have a grid, 10 cross 10 grid. And this is a good starting point. Now the next thing that we want to do is we have to draw the current piece. So if we have a current piece, which we don't yet have right now, we want to do is ctx.fillStyle equals to current piece dot color, not colors, color, and then current piece dot shape. So every piece has a shape that we defined, right? So the current piece will also have a shape. We have not yet written that one, but let's consider it has a shape. So we'll take the for each shape dot for each. It's not taking anything, it's taking the array because it doesn't know if it's an array or not. So it will have a value of dx and dy. So let me do one thing before doing the draw grid. Let me write our current piece function. So first of all, inside my update, I'm checking if I have a current piece or not. Now, if I don't have a current piece, I want to draw a current piece. So that is something that is not yet done. So let me try to do this one. So let me go to my current piece, which is the new piece. So here, first of all, I will create a type, and this is something that will be randomly selected. So maths.floor into maths.random times shits.length. Using this, we will get one of the three. And after this, we want to return few things. So we want to return a shape, and this is nothing but shapes type. Then we want to return a color. This is nothing but our colors type. And then we want to return an x and a y value. So this is the initial value of our current piece. So the y value is 0 because it is starting at the topmost row. And what is the x value? The x value will be something. So I will simply do it cols divided by 2. So cols is basically our column. So we are taking it at the mid column. So in case the column number is an odd number, so I will do a math.floor cols by 2. So we will return our pieces like this. Now in my current piece, so this is a piece with these values, this kind of values. So fill style, we can do a current piece dot color. Now inside my shape, what do I have? We will have one of these things. So we will have an array of 4 things. So when we are doing a for each, now inside we will have an x and y, right? So we'll do a dx dy. We will assume this thing exists because this is a shape. Now what do I want to do? We have a dx and dy, and accordingly we want to draw it at the exact shape. Now important part is this. Let's say we are not taking it, we generally take it like this. Let's say we have a shape. So then in that case, what we have to do is let s equals to not s, let dx equals to s dot x, let dy equals to s dot y. This is what we could have done. Now we are using a shorthand. We will directly take dx and dy here. We don't have to write these two lines. So now what is the value of x? So current piece dot x plus dx, and the value of y is current piece dot y plus dy. Now why are we doing this? We are taking x and y like this because the shapes are 0 0 1 0, this kind of numbers, and it is assuming that we are starting at the point 0 0. Now generally we don't start at 0 0. We could be at anywhere in the board, which is our dx and dy. So we are taking the current piece dot x and we are transporting, like we are translating to dx and dy so that we can draw the shape at that exact location. And then we'll do a ctx dot fill rect, and we'll do an x multiplied by side, y multiplied by side, and then side and side. Yes. So this is what we will do. And then we also have to draw a score. This is something we'll do later. This is not really important at the moment. So now if I come here, as you can see, we have different shapes forming at this at the midpoint of our x and at the top of our y. So this is fine. I believe this is fine, but these pieces are not moving, and that is a problem. So why they are not moving? They are not moving because in our update we are drawing our current piece, and but we don't have anything in the can move and the merge. So let's write our can move function next. So the can move will also have an x and y, and which is this x and y? This is the x and y just one position below of our current piece. Whether the piece can move over there or not is what we are checking. So in the can move, let's see what we can do. So instead of the x and y, I will do it as dx and dy because we have to find our real x and y. And we will also send a shape. So the shape, if we are sending the shape, that is fine. Otherwise, we will consider the shape to be the current piece dot shape because generally we will check our current piece only. So so we know that a shape is an array of mm, like array of arrays of many things. So we will return it true or false, right? So the can move will either return it true or false. If it is true, then it will move. If it is false, then it will merge. So 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 let me do it like this. So we will directly return, and what we will return in the shape for every value of shape, I want to check that whether this 0, 1 index is available or not. Now, inside the shape, we have we have the positions of x and y. So I will consider this ix and iy, and this is something else that came here. This is ix and iy. Now we'll create an x. So the x is basically our current piece dot x plus ix, and because we are trying to move, we will also add the dx. This is 0, so it's not a problem, but it can also be something else. And same goes for the y. So y plus iy and dy. So what is the iy? Iy is the different values of the shape. And this is something that we will check for all the values. So every shape has 4 values. So for 4 values, we will check this. We will create an x and a y. And then we will return something. So we will return if the value of x is greater than equal to 0 and the value of x is less than my columns and the value of y is greater than equals to 0. Uh, not for the y, not for the y. So the value of y should be less than rows. So what this means is x is greater than equal to 0 and x is less than columns. That means it is within this bound, left bound and right bound. So if I keep on clicking left, let's say like this, after this point, it shouldn't move more. So same for the other side. So this is the bound that we are checking, x greater than equal to 0 and less than columns. And also y should be less than rows. So what this means is when it is going down, the value of rows is 20. So it shouldn't be more than 20. So it should come and stop over here. This is the first part that we will check. And the second part that we will check is already in those locations in the board, there is nothing. There is nothing means we already don't have another piece over there. So we'll check y is less than 0 or there is nothing from the board. So the board y or there is nothing at the board yx location. So any of the three cases, if they satisfy, then we are good. And we have to add an and over here. So what this means is if our y is less than 0 or our board of y doesn't exist or our board of yx doesn't exist. So if any of the three cases are valid, so we have a true value over here. and which is fine. So this is clear. Yx doesn't exist, means yx is a null value, yx is empty. This is one case, and y is empty. What does it mean? It means that sometimes what happens is when we are clearing a line. So for example, when we will clear this line, another line will come at the top, another line will come at the top. So in that case, what will happen is the whole line will become null value. And we need to make sure that when we have a null value for the whole of y or an empty value, then also it should be a true value. And the third case is a y less than 0, which means that basically uh, the y value is above our screen, so above this line. So why this may happen is, I believe, when we are starting something, for a moment when we are rotating it, it may go above our screen. So in that case also, we should consider it to be true. So this is basically the case regarding which we will return a true value or a false value, whatever is the case. So we have made this one. Now if we refresh, we will see that our box is coming down, and we don't have new pieces because we are not creating new pieces. It will just come down and it will stop over here. So our game is progressing. This is not halfback, but what we have to do now is we have to create our rotate, and we also have to create our advent listeners. So when we are clicking left, right, and these things, we need to make sure that that our pieces move. So what we will do is we'll add a document dot add event listener. We'll add a key down, and here we will have an e, and we'll do a switch of e dot key, and here we'll have four cases: a, brick, and what do we want to check here? If we can move to -1 0. Uh, if that is the case, then the current piece dot x should be decremented by 1. Similarly, we will have four cases: a, then we'll have a d. So what does the d do? Instead of -1 0, we'll check the +1 0, and x will be increased by plus. We will have an s. S basically means we want to we want to go down first. So in that case, the y should increase by 1. And now for the last case, for the w, we want to rotate. We don't want to go up, we want to rotate. So in that case, we don't really need to check our can move. What we will simply do is we will do a rotate. Rotate. Now we need to write a rotate function rotate. We will keep this above our update, and we will then write this. So now if I come here and if I press, we can see that our box is moving. It is also moving right, and it is also coming down fast. Now if we press up, there is no rotate, so nothing will happen. This is anyway a box, so nothing will happen. So now let's see what we can do with our rotate. And I believe we can also increase the grid size now. Or yeah, we'll do it later. Let's see. So inside our rotate, what we want to do, rotate is actually very simple. We'll check if our piece can, I mean, uh, so our piece has different shapes. So for example, the eye has these shapes. So after rotation, what will be the new shapes? So rotate is like rotating by 90 degree. And if you think carefully, the rotate is actually something like this. If we have an xy, so after rotation, we will have a -y and x. Think carefully. So 1 1 will become a -1 1. So that is what we want to do basically. So rotated should be current piece dot shape dot map, and we will have what? We will have an x and y, and we want a return of a -y and x. Now that is not all. We need to check that if this is available or not. So we need to check if we can move to 0, 0. And here the shape, by default, the shape is the current shape. But here we need to pass actually the rotated shape. So we will pass the rotated shape that we got now. So if there is space, if there is space, so what we will do is current piece dot shape equals to rotated shape. Otherwise, we won't do anything. So now if we check for a box, it really doesn't matter. So as you can see, this one is rotating. So the box is also behaving strangely because the rotation is happening on the 0, 0. So there will be little bit change in direction, but yeah, as you can see, the rotation is working. So we have a good shape of our game right now. So our pieces fall down, we can draw, we can rotate, we can do many things. Now what we need to do is we need to merge when many pieces fall, and we also need to clear lines. But before that, there is also one more thing that I don't like in our game, and that is whenever we are drawing the shapes, so a line or a box or a J, for example, we don't see the grid lines inside the shapes. So we have these grid lines here, and it is totally vanishing when it is touching a shape. So this is a line, and we have a J. So what I want to have is I want the grid lines to be present inside our shapes also. I believe this will look good. Now you may argue that this really doesn't matter because grid lines are not part of the game. But yeah, I think it doesn't look half bad. So doing this is very simple, and that is we can simply draw the piece before our grid, and then this will be resolved. But I believe there is a better way to resolve this, and that is we can simply remove the grid lines. I don't think this is required. So we'll comment these things out for now. And what I want to do here is I want to draw a little bit smaller pieces. So instead of x dot side and y dot side, I want to start drawing at +3, and I want the dimensions to be -6. So now it will look something like this, and I believe this looks much better than even this one, for example. So we got a J, and we will get boxes and lines. Now we have our prime issue, and that is we only have one piece. We are not able to have many pieces. And why is that? So the reason is simple. We are updating. We have a piece, our current piece is moving, else it is merging, and our merge function is empty. So we have to write our merge function. And inside the merge function, when one piece merges, we can actually um, we can like call another piece. So what do we need to do inside our merge function? Now one thing is very clear that we can do is we can simply create another current piece. So current piece equals to new piece. Now if we do this, I believe at least half of the problem will be resolved. So yes, so this piece is gone, and we have another piece. And so we are getting lots of pieces, but the first piece is vanishing. Now, why is that? The reason is simple because we are only keeping track of one piece, and that is our current piece, and we don't have any other pieces. So, what the merge should do is there will be a structure forming at the bottom, and all the older pieces will be merging with this structure. So, unless we do that, uh, it really won't help. So, what we will do is we will take the current piece dot shape dot for each. So we have four shapes, and inside we will have a dx and dy, and we want to check that what is the x finally at the end. So we have a current piece dot x plus dx, and then we have a y, which is the current piece dot y plus dy. So we will have four sets of values like this. Now what we want to do is we want to check if y is greater than equals to 0. So y is greater than equals to 0 means this is within our board. If this is the case, then for the board yx, we want to set the current piece dot color. This is something we were not doing previously. So, so, so we are taking our current piece, and this merge function will only be called when our current piece is at the bottom. So at the bottom, I want to basically give this color to our board. Now, to understand what this means is if I simply do a console log of board at the end, and if I come here, so this box is coming down and it is here, and we have this. So these four became blue, and now another four became blue, and I think this will be overwritten now. So yellow, yellow. So so we can actually feel that these shapes are not coming down, which means it is keeping track of some shapes being formed, but we are not able to see those shapes. So those shapes are not yet present. So why they are not present? Let's try to understand that. So we will create a current piece equals to new piece, and we will also check one more thing. If I cannot move anymore, in that case, I want to do a game over, and the game over should become a true. I can console log the board also. And also when we are forming lots of shapes at the bottom, I want to clear lines. So we will clear lines one by one. When we have those lines, and we have to create another function called clear lines. But a bigger predicament is why we are not able to see the shapes that are already forming. So so whenever we have shapes, we will use a draw function to basically to draw our board. So we can do one thing after our switch case is over. Here we can basically draw our board once again, and let's see if this resolves the issue or not. So it's no good. It's vanishing again and again, but it will it will it will stay over there. So for example, it is keeping track of the shapes, but it is not basically it is not drawing them. So quite a big issue we have got ourselves into. And this issue is actually because of the lines in the draw grid that we have commented out. So we don't want to draw our grids, that's fine. But inside, for the board YX, we were also filling it with the required color, and that is also something that we commented out. And that is the reason behind this issue. So now we will have shapes like this, and when it comes down, we will have this thing. So definitely we don't want this. So what I will do instead is I will comment out the stroke rect. And when it comes to the fill rect, what I will do is I will do the same thing that I have done before. Inside will be -6 and -6. So we cannot simply mindlessly comment out these things. So we are writing a grid for a reason. And yeah, so grids are required. We simply cannot delete anything that we want. Yeah. So now if we see, our game is actually working fine. Only one thing that is missing is when we have lots of shapes below, the lines should vanish, and the lines are not vanishing. And why is that? Very simple. Our clear lines function is empty, and this is where we need to clear our lines when we have uh, the bottom lines not null. So we are assigning the color in our merge. So for the board YX, we are assigning the current piece dot color. Otherwise, the values are null. So if we check simply, there are a lot of null values. So what we need to check is if the last row uh, has no not null values, like has all the values are not null. In that case, we want to delete the last line and we want to add a new line at the top. So let's see how we can do this thing. So clear lines. So we'll start by writing a for loop. So let y equals to rows -1 and y is up to greater than equals to 0 and y minus minus. So this is our loop. Now what I will check is if the board y dot every cell. So if every cell is present, This means, so what does this mean? So it will check every cell. So board Y is basically our current row. It will start from the last and it will check cell 1, 2, 3, 4, 5 like that. So it will check every cell and it will return every cell only when the cell is present. So when every value is present, the value of this whole line will be true. Otherwise, it will be false. So we are basically checking the not null. So if all the values are not null, that means all the values are filled by a shape. So in that case, we want to clear the line. So what I will do is clearing a line means board.splice. We want to clear one row. So we will take the y. This is the start number and how many rows we want to delete. We want to delete one rows. Now that's not all. At the top, we also have to add another row. So I will use the unshift method and I want to add array false and the top row will be filled with null. And lastly, we also want to add our score. So score is something that we have defined at the top. Where is that score? Anyway, somewhere. So score should be 100 plus equals to 100. And lastly, we will also add the value of our y by 1 because we are removing 1. So only deleting is no longer sufficient. We have to increase it by 1. So now if we see if our game is working fine or not. So, okay, we cannot do it like this. I think we need a line. And yeah, so it got vanished. And now let's add our score because we are not certain that although the lines are vanishing, the score is adding or not. And I believe this game actually looks much better than this one. Actually, this is something I just came up on the flow, but yeah, it looks much better. So we will have a game over. So we have to do the game over thing, and let's also add the scores. So what we need to do now is here in the update function, we were checking if the game over is true or not. So when the game over is true, we were not doing anything. So what we want to do is we want to write a game over, something like that. So we'll do a ctx.fill style. Let me give a color of dark blue and we will fill rect. Uh, I think I don't want to make it entirely dark blue. What I want to do is I will do an RGBA because I want to give an alpha value also. So blue. So what is a blue? Blue is I believe 0, 256, 0. And let me give the alpha value of 0 0.5. I'm not sure if this is blue or not. Certainly I don't know dark blue. So for the dark blue, I think we can do an HSLA instead of RGBA. So HSLA, hue, saturation. Um, the last one is alpha value. So hue is something where we can define the color. So 240. Saturation, I think this is something we call 100%. And hue, saturation. Okay, I think that is fine. The last one, the L value will define how dark or white it is, I believe. I don't remember this one very well, but yeah, anyway, this is not the point right now. We will also fill the rect with this value. So canvas dot width, then canvas can move canvas dot height, and we will also give a ctx font of, let me give 40 pixel Arial, and then we'll do a ctx dot fill text. We'll write game over and we'll give 150. So this number, this number should be somewhere at the center. So 150 and I believe the height is 500, right? So 150 comma why 150? Because game over also has a value of x, so that's why 150. Okay, so I think that is fine. Fill text, we don't need a fill rect. What we will simply do is we'll do a return. Now let's see. Box. Ah, so something bad is happening. Okay, so let me change this to dark blue only. Dark blue. We are playing with fire, looks like. Oh, one more thing. The font doesn't have a fill style yet, so the font should also have a fill style. So let me give the fill style of the font to be white. Now let's see the game is working fine or not. Ah, so game over will come like this, but it's coming at the wrong place, looks like. So where are we making a mistake? Let's try to find that out. So we'll search for the game over. Initially it is false. And then we are assigning it to true to can move. When we are not able to move, we will assign the game over to be true. And this is where the mistake is. Because the can move function accepts two arguments, the third argument is defined, and we are not passing any arguments over there. So here we need to check that when we have a current piece, and a current piece right after declaration it is not able to move. So when it is at 0, 0, then we will make the game over to be true. So now I believe it will work perfectly fine. So let me just stack the pieces together. And yeah, so we have the game over at the correct place. So let me now try to give the alpha value because I think the remaining things are working fine right now. So it's hue, saturation, alpha, lightness, I believe. So hue, let me give to 40, 240, saturation 50%, lightness 75%, and 75%, and alpha value let me give 0.8. Now let's see how does it look. So let me stack all the pieces, and it will come like this. Hmm. I think it's not half bad. I think the lightness instead of 75%, it should be 25%, then it will be more dark. And this is anyway bluish in color. So now let me just do a game over once again. Let me force a game over. So it's changing color or it looks something like that. But yeah, anyway, I will leave it up to you uh, because I'm not sure why this is happening. But yeah, it's not half bad. So the only thing we are left with is we have to add the scores. So when we are drawing, we also need to draw score that we didn't do last time. So let me just add a score. So ctx.fill style, let me give the score to be white in color. ctx.font, let me give a 20 pixel Arial, tx Arial. And lastly, ctx.fill text will give the score to be something like this, score, and we'll add the score here, score. And the position, I believe, at the top left corner. So we have a score like this. I think we can make it better. So instead of 10, let me give 30. Now, yeah, now it looks better. Let me give 25. 25. Yeah. So let's see, scores add or not. So let me play a short game. Mm, and we have 100. So scores are also adding, things are working great. Now we'll get 200. So now we will end by adding the remaining pieces. So we have only added 3 pieces, but we can have a lot more pieces. So we have red, blue, yellow. Then we'll add a green. Let me give a light green. Let me give a white. No, I think white is not that good. Orange, violet, and another interesting color, if there is anything, if we don't have white, orange, violet, magenta, maybe, if we can give a magenta. And we will add few more shapes. So we will add an L shape, and then we will add S, we will add a Z, and we will also add a, I believe, a T shape. So these are for the L shape, the S, the Z, and the T. Now let's add these shapes. So for the L shape, this is very similar to our J shape, and I will simply copy the values. I don't want to write. So this is for our L shape. Think carefully. If this is the L shape or not. Very similar to this. So 1 1 1, and then here it is 0 1 2, and instead we have a 2 0 instead of a 0 0. I mean, yeah, just think about it. It will be something like this. Then comes our S shape. So S will be something like this. Could be a little bit tricky, but not much. Just think on it and you will find it. Then comes our Z shape, just opposite of our S. So let me add our Z shape. And then we are left with a T shape. So let me also add the T shape. So the T shape will look something like this. And we have all of our shapes. Now let's see. So we have a Z shape coming, then a red, then a box, then S, score of 100. Now this, and an L. So quite an interesting game we are having, but we are not able to form a line because we need an eye, and getting an eye is difficult because there are so many shapes. So I think we will have a game over soon. Even if we have an eye, so it's game over. Yeah. So what I believe is happening is it is happening 3 times. So that's why. So I think instead of an HSLA, I will just make it dark blue. Um, so this is how we can do it. And also let me just improve. Let me just add more rows and columns. Um, the gap between the boxes looks bigger now because we have everything bigger. If we have a 20 and 25, 25. So what we can do is in the draw, we are subtracting 3 and 6, plus 3 and minus 6. So instead of that, we'll add a plus 1 and we'll add a minus 2 because now we have a bigger board. So now I think this game looks very good. And we can also make it a little bit faster, and we can add levels actually. So in the earlier levels, we will have, let's say, half a second, and in the later levels, we can do it in a quarter of a second. So now, yeah, now this looks interesting. So I think we can make it faster. I think 100 milliseconds. No, I think this is too much, but yeah, anyway, you get the point. So you can play around and find out what you want to do for your game. But this is how we can make it a Tetris game. Very simple in HTML canvas. Now, make sure to give me more ideas in the comment section. What more things can be added here? I think we can add some bonus like some explosion kind of thing. If that comes down, there will be an explosion and a 3x3 box. It will empty a 3x3 box or something like that. There could be some rockets that clears up lines or something like that. So yeah, we can think on many things, but yeah, that's it for this video, folks. And I will see you soon with another very interesting video. So see ya.